Ensuring a smooth transition between network distributed 5.1 and locally produced stereo audio material is a common challenge for regional broadcasters. Our Upmix cost option feature automatically creates a 5.1 surround mix from any stereo audio source and makes it available for manipulation. Upmix 5.1 can easily be downmixed back to stereo without introducing audible artifacts.
The 5.1 Upmix option automatically creates centre, surround and LFE channels from a stereo input source. It is available on any stereo channel that is routed to a 5.1 mixing bus. I've got a stereo signal coming in here. We're routed to program 2, which is a 5.1 bus. And to initiate the upmix process, all I do is select the standard pan option to the encoders. Normally, a stereo source will be assigned to the left and right channels of a 5.1 mix. We have obviously standard front-back panning available, so we can send the channels to the rear. And we have a divergence that, in conjunction with the width control, allows us to narrow the stereo image and send it to the center speaker. For example, I can do a narrowed image, and you can see now that we are actually, as we narrow image, using the stereo across the front speakers of the 5.1 bus. However, this is not generating a different center signal, and the same way as panning to the rear is not generating a separate surround signal. The algorithm does exactly that. Let's have a look at how this works. When I select Upmix, this automatically assigns the Upmix parameters to the pan encoders, replacing the standard width, front, back and divergence modes that we would have with a stereo source to a 5.1 bus. I am now effectively removing the center component of the stereo mix and redirecting it to the center speaker, and then redirecting the ambience contained in the stereo mix to the rear speakers. There are 3 primary parameters and 2 secondary parameters. The divergence control affects the front image. It controls the spread between the 3 speakers, and it also allows us to remove the center component in its entirety. By increasing the divergence towards 100%, then the center image is removed completely, as you can see on the meter there. This means that we can create a 4.1 upmix, which is very useful in sports production. It keeps the center channel free for commentator dialogue. On the second page, which we get to through the mode switch, is our bias control. This affects the front-back balance, and it allows us to bias the image between the front and the rear speakers. Again, for music, front bias is the most appropriate method. For ambience, audience applause, crowd noise, then rear balance puts the listener effectively in the middle of the sound field. Again, as we change the bias control, front dominance, changing the bias towards the rear, and now the rear signals are louder than the front signals. At no point are you completely removing the front or rear components. It is purely adjusting the dominance of the front or the rear speakers. There's also an additional center trim that allows us to trim down the center level or raise the center level within defined boundaries. It doesn't go from infinity to +10, it's limited to -6 to +3, just to give you a fine tune over the center component. On the final page, we have a feed to put a sum of the signal into the LFE signal. This just puts a mono sum through the subfilter into the LFE channel. So between those 3 primary controls, LFE gain, bias and divergence, 2 secondary controls, which is the center trim, and there's also a front-back depth control that is normally left in its center detented point, but again can be used to effectively send more information to the rear speakers. Above the fader label is a second soft key which allows us to return to the stereo panning controls, because if we were feeding both a 5.1 bus and a stereo bus, we can use standard stereo panning in parallel with the upmix circuitry to feed a separate stereo mix. We have access from here to our upmix controls or our standard panning controls.